Howdy, PreCal. It is Miss Kosh. I am finishing up the 1B notes talking about even and odd functions. And so an even or odd tells us if there's symmetry with the graph. Okay, so even functions are symmetric about the y-axis. So that means I can fold this over here and I have symmetry. Whatever shows up in quadrants 1 and 4 also shows up in a similar way in quadrant 2 and 3. So for example, let's say I have the point, well, what do I see here? I don't know. Let me come up. Let's just talk about y equals x squared. In y equals x squared, I have 1, 1, and I have 2, 4, and I have negative 2, 4. Okay, so what I'm finding here, well, and it keeps going. I just ran out of space, and it should be more curved. So this I'm saying here, my f of 2 was equal to a positive 4, and my f of negative 2 is also equal to a positive 4. So what's happening here is f of negative 2 is equal to f of positive 2. So the definition of an even function, this could be any number. It could be 2, it could be 10, it could be a trillion, it could be anything. F of x will equal f of negative x. Actually, I usually write f of negative x equals f of x. Yeah, change that. Scratch what you have. Tell me, I mean, it's the same idea, but we usually start with this and we're trying to see that it equals that. The coordinates, so x, y will also give us, we'll have a negative x will also correspond to that same y value. And here's what we see. There's symmetry here over the y-axis. It all folds over. If you ever see a situation, or if they ask you, does it have symmetry over the x-axis? What happens with that, really fast, is if I have symmetry over the x-axis, that means whatever's here is also there. Is this a function? It is not. So if it tries to say my function has symmetry over the x-axis, you're like, wait a minute, it's not a function because it has failed the vertical line test, except in the polar world, but we're not talking about that yet. Okay, so then an odd function has symmetry about the origin. So it's going to have, so in my cubic function, when I have 1, 2, 8 is going to be a point. So if I have y is equal to x cubed, and I say, okay, let's plug in, or let's call this f of x. F of x is equal to x cubed. If I do f of 2, 2 cubed, 2 times 2 times 2 is equal to 8. Well, what happens when I have f of negative 2? Well, I have a negative times a negative is a positive, times another negative is negative. So this is equal to a negative 8 down here somewhere. And so my notation is f of 2, or f of x, no, I lied to you. F of negative is going to be equal to the negative, hang on, let's write it this way. F of negative x is equal to negative f of x. So when x is 2, notice f of negative 2, right here, f of negative 2 was negative 8, is equal to negative f of x. So this 8 became a negative 8 because it's an odd function. So x, y now goes to a negative x and negative y. So I had a positive 2, positive 8, negative 2, negative 8. Hopefully that wasn't too confusing. So we're going to determine if they're even, odd, or neither by plugging in negative x and seeing what happens. So f of negative x will be 3 times negative x cubed plus 2 times negative x. This, a negative times a negative times a negative, there's 3 negatives, is still negative, so this is negative 3x cubed minus 2x. And I can factor out a negative, and I'm back here, and this is exactly what I started with. So this is equal to negative f of x. And I just showed f of negative x equals negative f of x, which is odd. Okay, let's try the next one. Okay, a negative times a negative is a positive, so this stays negative 2x squared plus 5. This is exactly where we started. So I just proved that f of negative x was equal to f of x, which is even. Okay, let's look at this one. F of negative x, I have a negative x cubed minus negative x squared plus 4 times negative x plus 5. Negative times a negative times a negative, that's a negative x cubed. A negative times a negative is a positive, but there's still a minus out front. This is a minus 4x, this is a positive 5. Is this exactly where we started? Well, no, because these two changed signs, but these two did not. Is it exactly opposite? No, parts of it changed and parts of it didn't. This is neither even nor odd. Okay, let's look at this one. F of negative x is equal to negative x to the fourth minus 2 times negative x squared plus 4. If I have four negatives, I have a negative times a negative is a positive, a negative times a negative is a positive times a positive is still positive. This is a positive x to the fourth. This becomes a positive x squared, but times a negative out front. This is exactly what we started with. Therefore, dun, 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 it's even. All right, like, subscribe, comment, and go practice. Good luck to you.